Okay guys, it's been a while since I posted a video. It's just been so kind of hectic and unusual, the times that we're living in right now, so it's just been very difficult to actually spend some time on this stuff. But anyway, I just thought I'd upload this just to give you guys let you know I'm still alive and I'm still working on this stuff. And still committed to the cause, so to speak. It's just haven't had a lot of time to do it, unfortunately. I just wanted to kind of go over what I've been doing with this Andrei Melenchenko circuit. Chris put this up for us, which is really nice of him. And so, you know, I watched a cooler video on how this coil was wound. That's on our thread there. And to me, what it looks like, he's got, you know, you got your bobbin, okay? You take the first layer, or the first wrap around that is this, you know, copper, you know, very thin plating. It's like a 1/10 of a millimeter, I believe this is. And that goes around, you know, it's not all the way around this. If you look in the cooler video, there's a gap of about 1 centimeter or so. So mine starts here and wraps around, stops about here somewhere. So you take the first wrap, and then you solder. You need to solder a wire that's going to come out of it, which is this black one, and then you solder the beginning of your coil winding, which I use this 30 gauge wire. I think this might be a little thin, to be honest, and that might be some of the problem I'm having. But then you solder this wire, you know, onto your shield, okay? And that's the beginning of the coil. And then wrap that around the bobbin, tape that off. This is what I did anyway. And then you wrap your first, you know, and in the video of the cooler video, you see him. The inside coil looks like he does 26 arm lengths on this first section when he's disassembling it. So I did about the same, right? I actually made quite a few videos of me doing all this stuff. I may post them, I'm not sure yet, I'll see. I've made some stupid mistakes, and I had to redo this several times, but just remember, when you're testing your inductances, you got to make sure you have it inside the core. But anyway, once you wrap your first, you know, coil around, then, you know, you leave yourself enough to do your hookup, okay? And then you tape that one up. That's what I did, in just a couple of layers of black electrical tape. And then you get your next coil, you know, the same wire, and it's the same direction. You wrap the next one around. I had to keep wrapping and wrapping till I got the right inductance for this. But basically, if I did the, you know, I think it was 23 pulls, it looks like, of wire, 23 arm lengths of wire that a cooler had on the second one. So you wrap that, leave yourself on the beginning of the wrap enough for your connection, you know, wrap the next one up, and then when you get to the end of that one, you need to take another piece of this is how it looked like in the video to me, another piece of your copper, solder the last wire, or the end of the coil wire, onto that, wrap that around, tape it off, but make sure you solder another piece that's going to come out of there. I guess what you could do, you could probably scrape this down a little bit and solder it. You don't even have to cut it, and then just so it's soldered onto this, okay? So at least you still have a hookup. And then that goes around, and then you tape that up, and that's basically what this is. Now, to get the inductance right, for me, with the inner coil, the inductance was too high. So what I thought I could do is, if you just split the core a little bit, you know, it changes the inductance quite drastically. So, and it worked out perfectly for me if I put 2 bits of cardboard in there, you know, and then pop the top back on. Then I had exactly 22, you know, millihenries for the inner coil. So I thought, okay, well, I'll just wind the outer one to 54 and see how that goes, right? Now, I'm not sure if that's the best idea. I think maybe I should have just tried to get the inductance right with this core together. So I probably should have just removed some turns. But anyway, I am where I am right now. I might have to start all over again on this, but just kind of bear with me. So anyway, what I tried to do is just splitting the core apart to give me the correct inductance. And when I had these two little strips of cardboard, that made it perfect. And then I started winding the second coil, and I just had to keep winding and winding, which I ended up putting nearly double the amount of length, I think, of wire Akula had in his video to get the 54 millihenries with the gap of 2 pieces of cardboard here, right, with these 2 shims in there. So that was kind of how I went about getting this built, and that's what it looked like in the video to me. That's how it was disassembled, so that's how I put it back together. I think that's what it looks like to me. Anyway, I've been playing around with this for a little while. You know, I notice here, obviously it says, where's the voltage? Where is it on the board? I think, what did Chris write on there? 9 volts. So Chris had 9 volts written on there. So I'm thinking, okay, obviously we can go up to 9 volts on that. And depending on the voltage you put into this, really varies the signal that you get out of it. So very different at 2.5 to 9, you know what I mean? So right now I've got it set at about 8.6 volts. And if I give this thing some power, let's get a little juice here. Okay, it's quite loud. It's because it's vibrating a lot here. I try and put some pressure on that, quieten it down. You can see the waveform I get. Now, the pink trace, okay, is on CN1. So that's the 22 microhenry. So that is the inner core coil. And the light blue trace, okay, is the 54 millihenry coil, and what's the other one? The dark blue is the MOSFET. So that's the waveforms I'm getting. I'm not getting those, you know, kind of interference. They look like compression, and it almost looks like some interference on Jagao's video there, which looks like it's supposed to be, and I'm not getting that. So mine's definitely not as good as his by the look of it. It's not getting that same effect. The one thing I noticed, you know, even in Akula's video, or it might have been, if it's Andrei Melenchenko that was doing it, but his didn't work until he had the screw and this thing tightened. So I'm sure that the inductance is a big issue. You got to get it just right. And I'm just not exactly sure the frequencies we're meant to be getting, because mine's only running here at 40 hertz, which is way too low. And then if you look at this, I'm just going to turn this off. Like, if you do the and another thing to look at here is on the 54 millihenry coil, you can see that that's oscillating with this 510 nanofarad cap. Okay, so that's saying that we should give us 959 hertz at you know, it should resonate at that. I think I've got that right. But the one thing, if you look at this circuit, how this chip, this MC34063 is meant to run, on the spec sheet, they have, if it's a step-up converter, they say that it needs to be 170 microhenries. If you look, that's the same one. Where is it? Step up. We want the step up. Yeah, step up converter. See, it's got the same 180 ohm resistor going through 170 microhenries, and we're at 54 millihenries. So I don't know what a cooler or, you know, Andrei Melenchenko are using, but it seems like it's telling you you have to have that for it to oscillate correctly. Anyway, something to think about. Anyway, so that's kind of that. I do, you know, I notice when I play around with it, I do get like, it's not doing it right now, but sometimes I can tune it to a point where once I let the power off, I'll get like 2 or 3, it wants to keep going and then dies. But I just have this feeling that I need to just go back to the drawing board and start the winding on this again. I don't know if anybody knows what size wire the cooler was using. Maybe it's 28 gauge. I think 30 might be too fine. Anyway, that's kind of where I'm at, guys. I'd like to post some more videos and you know, get into this a bit more. It's just time has been really tough lately. All right, cheers.